Short lesson on elimination. Elimination is another way of solving linear systems. You want to find the point of intersection between these two linear relations. Okay. For elimination, it works if you have all the x's on top of each other, or all the variables have to be the same on top of each other. So x's on top of each other, y's on top of each other, equal signs on top of each other. The other side, they have to be in the exact same order, your two equations. So I want to number my equations, equation 1, equation 2. And what I can do is I can add or subtract my equations, try and get rid of one of the variables. So in this case, I'm going to add my equations. I'm going to take equation 1 plus equation 2. I want to add it because I know when I have 2 plus negative 2, it's going to end up with 0. And that's what I'm looking for. So 3 plus 5 is 8x. 2 plus negative 2 is going to give me 0y equals 19 plus 5 is 24. I added the two of them, and it's a good idea to put two equations. It's a good idea to put little plus signs in all these spots that you're doing. Just helps you keep things straight. 0y is just 0, so you can kind of ignore it. So 8x equals 24 is really what I'm left with. 5 both sides by 8, x equals 3. Now when you get the one variable, you have to go back and find the other variable. So you're going to do a little bit of substitution. Sub x equals 3. And it doesn't matter into which equation you choose, so choose one. I'm going to choose equation 1. So it'll be 3 following equation 1, but put an x in. 3 times 3 plus 2y equals 19. So I'd have 9 equals 2y. 9 plus 2y equals 19. Take this plus 9 over the other side, becomes subtract 9. 2y equals 19, subtract 9. 2y equals 10. Y divide both sides by 2. 10 divided by 2, y is 5. And there's your answer. Therefore, x comma y equals 3 comma 5. Add or subtract your two equations if they're identical order on top of each other to get one of the variables to go to 0. Once you do so, you can find your other one variable, the remaining variable, and you sub it back into the equations to go back and find the final variable. Okay, so you want one of your variables at the start to go to 0. It doesn't matter which one, whatever will work. Second equation, or second question here. I have two equations. The x's are on top of each other, y's are on top of each other, equal sign. They're all in the exact same order. Perfect. Now, neither one, if I add or subtract, I'm not going to get either one of these to go to 0. So I have to do a little manipulation first. In this case, I want to try and get rid of the 12s. Get rid of the x's. And I want to do so by making them both 12s. So I have equation 1, I have equation 2. If I get them to a common common coefficient, then I add and subtract them and make them go away. So if I take equation 1, I want to multiply it by 4. The entire equation 1 by 4. That will give me 12x plus 8y equals 8. I take equation 2 and I multiply it by 3. That will give me 12x plus 15y equals 36. So I've just adjusted both my equations in order to get them to have the same number on one of the variables. Now they're both 12s, and now I have to figure out, okay, am I going to add these or subtract these to make them go to 0? Well, if I add them, it'll go to 24. That's not going to help, so maybe I should try and subtract them. So I'm going to go to equation 1, subtract equation 2. Put a line underneath, put a little subtraction sign at each spot to let me know what I'm doing. 12 subtract 12 is just 0. 8 subtract 15 is negative 7y. And then I have 8 subtract 36, which is negative 28. Okay? So I have negative, so that 0 basically just disappears. So I really just left with negative 7y equals negative 28. Divide both sides by negative 7. And y equals 4. Like before, when you got the 1, you solve for the one variable, you need to go back and find the other variable. I have to go back and find x right now. So I'm going to sub y equals 4 into and choose an equation. I'm going to choose equation 1. So I have 3x plus 2 times 4 equals 2. I followed along with equation 1, but I replaced the y with the 4 value that I solved for. 3x plus 8 equals 2. 3x equals 2, subtract 8 by taking my plus 8 over to the other side, turn to subtract 8. 3x equals negative 6. And I'm going to divide both sides by 3. X equals negative 2. Okay, so now I have found both variables. I have to do the one by elimination, where I add or subtract my equations, make one of the variables go to 0. And then once I got one of my variables, I sub back into one of the original equations to solve for the other variable. Therefore, x, y equals negative 2 and 4. This is the point of intersection between those two linear relations. Short little lesson on elimination. Thank you very much.